Hello everyone, I am Suchita Moore. Welcome you all in the video lecture on the topic Inverse Laplace Transform. Inverse Laplace Transform play an important role for solving various engineering problems. Inverse Laplace Transform. If f of t is a function of t and Laplace of f of t is denoted by capital F of s or f bar of s, then f of t is called inverse Laplace transform and it is denoted by this Laplace inverse of capital F of s or Laplace inverse of capital f bar of s is value equal to f of t. That means when we applying Laplace to t domain, time domain, it converts into s domain. And when we Laplace inverse is the inverse Laplace operator. And when S Laplace inverse apply to S domain, it converts into T domain. Now we derive some formulas. Here already we prove these results Laplace of 1 equal to 1 by s. Now from this we easily write down the Laplace inverse of 1 by s, its value equal to 1. Now for second formula, here n factorial right hand side, n factorial which is the constant value, we can write down this as Laplace inverse of s to the power n plus 1 equal to t to the power n upon n factorial. We can write this n factorial in left hand side or right hand side. Maximum times we shifted this on right hand side. Laplace inverse of third formula e to the power at equal to 1 upon s minus a. Therefore, Laplace inverse of 1 upon s minus a, its value equal to e to the power at. Similarly, fourth formula, here again in right hand side a is the constant value. Therefore, Laplace inverse of 1 upon s square plus a square, its value equal to 1 upon a sine a t. Now, fifth formula, this is for by applying force shifting, that means Laplace of e to the power at into sine bt. Here, right hand side a is constant value, therefore Laplace inverse of 1 upon s minus a whole square plus b square, its value equal to 1 upon a e to the power at into sine bt. Now, next formula here, instead of plus sign negative sign e to the power minus at into sine bt. Here again a is the constant value in the right hand side of the numerator, therefore 1 upon s plus a whole square plus b square equal to 1 upon a e to the power minus 80 into sine b. In this way, we write down the all formulas of Laplace in terms of Laplace inverse. Now we discuss example on this Laplace inverse. Find Laplace inverse of s upon s to the power 4 plus s square plus 1. Now here we solve this problem by two methods. First is adjustment and second is partial fraction method. Now here we consider denominator term s to the power 4 plus s square plus 1, and we write down this in the form of by adjustment here s square plus 1 whole square minus s square, and then apply the a square minus b square formula, that means s square plus 1 minus s, and second factor is s square plus 1 plus s. Now these are the factors, therefore we can solve these by partial fraction method. Therefore consider s upon s to the power 4 plus s square plus 1 and apply here partial fraction method and write down the value. Here s square plus 1 minus s. Second is s square plus 1 plus s. Now by partial fraction method, we write down here denominator term is s square minus s plus 1 and therefore numerator is as plus b and second term is s square plus s plus 1 and numerator term is cs plus d. Now here we are interested in finding the constant values a, b, capital C and d. Now for this we taking LCM and simplify the terms. Therefore, your left hand side is s upon s to the power 4 plus s square plus 1 and then by taking LCM here s square minus s plus 1 into s square plus s. Now here on cross multiplication as plus b into s square plus s plus 1 and plus cs plus d into cross multiplication s square minus s plus 1. Now here denominator term get cancelled. This is the same values. Now open the bracket in right hand side and combine the terms of s cube, s square, s and constant term. Therefore open the bracket here a s cube plus a s square plus as. Then multiply by b to the bracket. Therefore b s square plus bs plus b. Now second term cs plus d into this term second bracket, therefore multiply by cs cube minus cs square plus c and plus d into second bracket, therefore ds square minus ds plus d. Now combine the terms. Here we combine s cube term. Here first term s cube, that means a. Then second term is c plus c s cube. Now we combine the terms of s square. Therefore a plus b, then minus c and plus d s square. Now next we combine the terms of s. Therefore here as, that means a. Now bs, therefore b. Then third term here is cs, therefore plus c and fourth term minus d into s. Now we write down the constant values. Now constant values are there, this b and remaining term d. Therefore b plus d. Now on equating, coefficient of s cube, s square, s and constant term. Then we get four equations. Now here in left hand side here s only, therefore coefficient of a plus c equal to 0. Therefore a plus c equal to 0. This is first equation. Now second equation is this value a plus b minus c plus d, its value equal to 0. This is second equation. Third equation is this a plus b plus c minus d equal to 1. This is third equation. Now fourth equation is b plus d equal to 0. In this way we get four equations. We solve these four equations by any method and find out the constant value. Now suppose from this first equation we find out the value of a equal to minus c. Here substitute in this equation, then we get a equal to, from first equation, a equal to minus c. Now we substitute this value in third equation, then third equation becomes b minus d equal to 1, and fourth equation is b plus d as it is, b plus d equal to 0. Now when we solve these two equations we get the value of b equal to 1 by 2 and d equal to minus 1 by 2. Now substitute these values in equation 2 or 3 and find out the value of c. That means if we substitute this in second equation, then we get a equal to minus c plus b is 1 by 2, then minus of c, d plus d is 1 by 2 minus 1 by 2, its value equal to 0. When we simplifying this, we get the value of c equal to 0 and therefore a equal to 0. Therefore this equation, that means this term s upon s square s to the power 4 plus s square plus 1, this value becomes a is 0, therefore only b value 1 by 2. Then remaining term 1 upon s square s to the power s square minus s plus 1. Now in second term c is 0, therefore only we substitute the value of d is minus 1 by 2, 1 upon s square plus s plus 1. This is the term we get by applying partial fraction method. Now we find out the Laplace inverse of this value. Therefore, we adjust the terms. Here 1 by 2 is taking outside and Laplace inverse of s upon s to the power 4 plus s square plus 1. This value equal to, we taking 1 by 2 outside. Then Laplace inverse of 1 upon this term we adjusted as third term, that means completing the square term, and then find out the Laplace inverse. Now second term as Laplace inverse of, here 1 by 2 is taking outside, that means here negative sign, and then 1 upon s square plus s plus 1. Now we simplify these terms, these and this term, by completing the square. That means here we find out the third term of this term. Here second term coefficient of s is minus 1. Therefore we divide by 2, that means minus 1 by 2, and its square, that means 1 by 4. We added this term and adjust the terms. Therefore, right hand side becomes 1 by 2, which is outside. Then Laplace inverse of 1 upon here s square minus s plus 1 by 4. Now here plus 1, therefore we added here 3 by 4. That means we get the value. Otherwise we add 1 by 4 minus 1 by 4, adjust the term. This is the first term. Now second term, Laplace inverse of 1 upon s square plus s. Again third term is same, 1 by 4 plus 3 by 4. Now 1 by 2 into Laplace inverse of, we adjust this term as completing the square, therefore s minus 1 by 2 whole square plus root 3 by 2 whole square. This is the first term. Now Laplace inverse of second term is s plus 1 by 2 whole square plus root 3 by 2 whole square. Now we apply the formula number 5 and 6 and find out the Laplace inverse. Therefore here Laplace inverse of 1 upon s minus of a whole square plus b square, its value is 1 by 2 into 2 by root 3, because 1 by a, then e to the power t by 2 sine root 3 by 2t. This is the first term, Laplace inverse by using the formulae. And second term minus here 2 by root 3, then e to the power, instead of here s plus a by 2, therefore e to the power minus t by 2 here, and sine root 3 by 2. This is the Laplace inverse. Now we simplify this here. 2 by root 3, we taking outside, these two get cancelled, that means we get 1 by root 3, then sine root 3 by 2 p, which is the common from both the terms. Remaining term is e to the power t by 2 minus e to the power minus t by 2. Now this is the answer, or we can write down this value as 1 by root 3 sine root 3 by 2 t. Now if we adjust here by 2 term and here multiply by 2, that means we get this value as sine h t by 2, and which is the required result. That means Laplace inverse of s upon s to the power 4 plus s square plus 1. In this way, we find out the inverse Laplace transform of the function of s. Thank you.